Welcome back to another picoGym workout challenge write-up video. In this video, we'll be walking through the forensics challenge tunnel vision. Let's get into it. We found this file, recover the flag. So you can download the flag and you could run binwalk and file on it if you wanted to try to determine what kind of file it is, but that's not going to work because the data in it is corrupted. So it's not going to give you a valid result back. But we can fix that simply by dragging it into a hex editor and seeing what kind of file it is. So whenever a file starts with BM424D in hex, that is a bitmap file. So what we can do is quickly change this to .bmp. Try to open it. Okay, so it's more than likely corrupted. Now, the easiest way to figure out what's corrupted in it is by comparing it to an actual bitmap that is working. So here I have an almond bitmap, and we're just going to compare it to this inside HXD. So I'm going to drag that back into HXD. Okay, and then I'm going to drag the almond.bmp into HXD. And then what's cool is we can do window tile vertically. Hang on, there we go. And now we're going to be modifying our tunnel vision to look like our almond.bmp. So right off the bat here, we have these, well, the header looks correct, right? The header looks fine. But what doesn't look fine is these values right here. So if you notice, it kind of says bad and bad. And those are supposed to be static values. So if you look at our almond.bmp, they say 36 and 28, and then a null byte and a null byte. So let's go ahead and change that. So 3600 and 2800. All right. Now if we save it and we try to open it. Oops, wrong one. It's fixed, kind of. There's a false flag here, though. That's not the picoCTF format, so don't be fooled and try to submit that. Now, the challenge is called tunnel vision. So what does tunnel vision mean? It means you're selectively seeing something and nothing around it. So that makes me think that there's a sizing issue, potentially. And if you kind of look here, it does look like the image is kind of cut off, sort of. It's just a weird resolution for an image. So we need to figure out which values inside the bitmap source code anyways, control the height of the image and width. So let's go to Kali really fast and let's run an exif tool on the tunnel vision bitmap that I already have loaded in here. And we'll notice the image width and image height are 1134 by 306. Okay. Now, an easy way to figure out what the height and the width are in hex, of course, is just by running Python. And we can just type in hex 1134. And we can do hex 306 for the height. Okay, so that's OX46E and OX132. So, if we don't need this one anymore, I don't think. Maximize that back up. And we bring this over here. Let's look and see if we can't find 46E and 132. Well, if you look at the next line here, we see 6E04 and 3201. So that means that the height and width of the image are in Little Endian, whereas if we just converted those values normally, this is just Big Endian by default. So it reads it in reverse, right? The byte's in reverse. So we need to keep that in mind when we're controlling the height and the width. Now, usually controlling the width messes up the image's pixel alignment, so it looks really strange, but the height value is probably what we want to focus on. So let's try something big, and I'm not going to beat around the bush here. I'm going to go ahead and show you what the height should be. If the height exceeds what the maximum height of the image is supposed to be, then it will return false. In fact, I can even show you that really fast. Let's do hex 1000. So that's OX3E8, so that'll be E803 for the height, which will be the second value, of course. So E803, if we do that, and we try to open the image, notice it failed. Well, that's because we set the height outside of the allowable boundary for the image's potential, right? Or what the image is supposed to be set at. It's not like a PNG where it doesn't matter. For bitmaps, that actually messes up the image. So we have to find a value that's smaller, but still reaches to the, or at least close to the maximum height of the image. And I found that 850 works. So let's do 850. So that's going to be OX352. So that's going to be 5203. So let's go ahead and put that in, 5203. All right, save that. Now if we open that back up, there we go. There's the flag right there. picoCTF, quite a view 2020. So now we will just submit that to our flag submission. I am struggling to type that for some reason. All right, let's submit. And it's wrong, and that's because I have an extra F there that shouldn't be there. Okay, that should be good now. All right. Awesome. If you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.